This is the fifth and hopefully the final part for 4.3, part E. And we're talking about solving logarithmic equations. Okay, so in one of the earlier parts, we did talk about changing the equation between logarithmic and exponential form. That was over here. So you could do that. But I kind of like to look at it a little bit differently. It just makes more sense to me. The way I think of it is I think of it as like exponentiating, which I don't even know if that's a word, but basically here's the base of 2. And so I take that base of 2 and I basically pretend that each of these is now an exponent for this big 2. So I'm now saying 2 to the power of log base 2 of x is equal to 2 to the power of negative 3. So then that allows me to cancel out this and this. Okay, and then I can bring that x down and I can say that x equals 2 to the power of negative 3. Okay, and that's basically the same thing that would happen if you used this over here. Right here. So, you've got log base 2 of x equals negative 3. You turn that into 2 to the negative 3 equals x. Okay, and this is how you're able to do that. That's why this even exists. So, anyway, so then 2 to the power of negative 3 is the same thing as 1 over 2 to the third power, which is equal to 1 over 8. Okay, so x equals 1/8 is the answer in that case. So whether you think about memorizing this guy or, doing it that way, it's the same thing. So on number 41, the base is understood to be 10. Okay, so then I just put like a big number 10 here and here, and that allows me to cancel out that and that, and it gives me x is equal to 10 to the power of 1, or in other words, just x is equal to 10. Number 42, same thing. So the base is 125. So I make that my base here. And then that lets me cancel out that and that. And then I have 1 over 25 equals 125 to the power of x. So now it's an exponential equation, kind of like what we talked about in 4.2, where you want to use, find a common base for both sides. So in this case, that common base is going to be 5. All right, so 1/25 is the same thing as 5 to the power of, well, I know 5 squared is 25, but if I want it to be 1 over 25, I need that to be a negative 2. And then do the same thing over here. So 125 is the same thing as 5 to the power of 3, and then that is still raised to the power of x. Okay, so you would multiply those exponents together, so it would be 3x. We can cancel out the big 5s now, and we can just bring down negative 2 equals 3x. And then we could just divide both sides by 3. So negative 2/3 equals x is the solution. All right. Number 43. So let's see here. Take base is 5, so big 5s here and there. So we can cancel out that and that. and that would give me 8 minus 7x equals 5 to the third power. So I know that 5 to the third power is 125. So 8 minus 7x equals 125. And then I would just subtract 8 from both sides. So that would give me negative 7x equals, that would be 117. All right, and then divide both sides by negative 7. So that won't go in evenly. So x is equal to negative 117 over 7. Now, I am remembering something that we talked about earlier, I think, in this section, which is that the domain of a log function is, from 0 to infinity. Basically, you can't take a log of a negative. So your argument, or whatever's in your parentheses, does need to be positive. So that's something we need to keep in mind when we're solving these. We could have some, what they call extraneous solutions, just like we had with like square root equations. Sometimes we had those extraneous solutions. Sometimes it was no solution. So extraneous solution is just whenever you come up with x equals a number, but then when you plug it back in, it doesn't work because it makes it like negative or something like that. So anyway, in this case, we're going to be okay because this is a negative, but if you plug it in here, it's a negative times a negative, so it becomes positive, so it's okay. But just that's something to keep in mind when you're solving a log equation. All right. All right, so number 44. Here we have a sum of logs. So the first thing we need to do is combine those. So using our properties, we combine those. So that's going to be log base 2 of x plus 1 times x minus 1, still equal to 3. Okay, so two things are going to happen. It doesn't matter which one we do first. One thing that's going to happen is we're going to FOIL those, and the other thing that's going to happen is we're going to get rid of the log by putting a big 2. Okay, so we can maybe even combine those steps. All right, so we put the big 2 there, and then we're able to cancel that and that. All right, and then let's see. All right, so we've got, this is equal to 2 to the power of 3. We're going to FOIL, so let's go ahead and FOIL that. So that's going to be x squared minus 1x plus 1x minus 1. Okay, and now let's just, basically we've got a quadratic equation happening here. So let's combine those. Well, those are actually going to cancel each other out in this case. So we would end up with x squared minus 1 equals, and then 2 to the power of 3, 2 times 2 times 2, so that would be 8. All right, and let's go ahead and add 1 to both sides. So x squared equals 9. And then let's take the square root of both sides. So then that, when you take the square root, that's going to make it plus or minus 3. Okay, however, so if you plug in a positive 3, you're good because 3 plus 1 is 4 and 3 minus 1 is 2. But if you plug in negative 3, you're not good because negative 3 plus 1 would be negative 2. So you can't have a negative argument inside a log. So go ahead and just throw away the negative option and say x is equal to positive 3. All righty. And number 45. So in this case, the base is an x. So I'm just going to put like a big X here and there. And then that allows me to cancel that and that. So I can bring down the 27. So 27 equals x to the power of negative 3. Okay, so x to the power of negative 3 is the same thing as 1 over x to the third power. Okay, so I would have 27 equals 1 over x to the third power. So now in order to solve for x, I need to get it out of the denominator, which means I'm going to multiply both sides times x cubed. So I'm going to have 27x cubed, and that's going to cancel out, so that's going to be equal to 1. Okay, and then I'm going to divide both sides by 27. So now I'm going to have x cubed equals 1 over 27. And then to solve for x, I'm going to take the square root, or rather the cubed root of both sides. So that would be x. And then the cubed root of 1 is 1. And the cubed root of 27 is 3. Because 3 times 3 times 3 equals 27. So x equals 1/3 is the final answer. And number 46, the base is x plus 2. And so I will write a big x plus 2. So this can cancel. Bring down the 81. And then I basically have x plus 2 raised to the power of 1. So x plus 2 raised to the power of 1 is just x plus 2. So I've got 81 equals x plus 2. And then I'm going to subtract 2 from both sides. So that's going to be 79 equals x. And that's my final answer. And I believe that we are finally finished with section 4.3.